Hello, and welcome to today's lesson on scientific inquiry. We're going to be talking about scientific tools and measurements and scientific notation. There are a number of different tools we'll be using in Science Lab. They include beakers and graduated cylinders, which we will use for measuring liquids, thermometers, which are used for measuring temperature, balances, and a balance can be either a digital balance or a triple beam balance. And we will likely use both of those over the course of the year. And for measuring lengths of things, we will be using meter sticks and rulers. All of our measurements will be using the International System of Units, which is abbreviated SI. It's also known as the metric system. And in all scientific publications, all measurements are use the metric system for a couple of reasons. Mostly because most of the world uses the metric system. But it's also important that everyone uses the same units so that there's no confusion when you're reading someone else's research.
Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Let me start with the ways you can measure a distance, like the height, mad, tall, or super small. One of these will do you right. If you try walking a meter, it's easy to complete because a meter's just a little bit more than 3 feet. But if you walk in a kilometer, it's gonna take a while. It's 1,000 meters, that's over half a mile. A centimeter's dinky, the width of your pinky. 100 of them go into a meter. You still with me? There's another kind of meter smaller than that. It's not very fat, it's called a millimeter in fact, and it's tiny. 1,000 of them in a meter fit, that's 10 in a centimeter, and that's it. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Now we moving on to the liters, measuring liquids and containers. We only got two, it won't take long to explain this. A liter is half a big bottle of soda pop, and a milliliter, it's just about 20 drops. There's 1,000 milliliters in a liter, you know. So if you got both of those, you're good to go. So now we can move on to the grams, measuring weight, kilograms, milligrams. Yeah, we keeping them straight, it's pretty simple. A paper clip weighs about a gram. A big textbook is a kilogram, man. But a milligram, it's a little harder to slice, cause 10 milligrams is about a grain of rice. 1,000 milligrams is a gram. 1,000 grams in a kilogram. Now we got grams, we also got liters. Put them all together with the meters. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system. Meters, liters, and grams. Now you don't have to cram for your exam on the metric system.
Well, I hope you enjoyed that little video, and we're going to continue with our discussion on scientific inquiry. As you recall from the video, our three main measurements in the metric system are meters, which we use for length or distance, and a meter is 100 centimeters. A kilometer is 1,000 meters, and you'll see that these prefixes are consistent throughout all of the different measurements within the metric system. For volume, we use liters. I'm sure you're all very familiar with a 2-liter bottle of soda. If you look at your water bottle that you may have in your hand right now, it will tell you its volume in liters or in milliliters. There are 1,000 milliliters within 1 liter. And for mass, we use grams. You may know your weight in kilograms, or you may see things labeled with their weight in kilograms. Now, scientific notation is a way of writing really big and really small numbers. And later on this year in math class, you're going to learn how to add and subtract and multiply and divide numbers in scientific notation. Here in science class, we're not going to worry about that. We are going to worry about understanding the difference between a number in scientific notation and what that number is in standard notation. So for example, if you were to write down the number 1 million, you would have a 1 with a whole bunch of zeros after it. The same number in scientific notation would be 1 times 10 to the 6th. And we're going to spend some time in class practicing converting numbers between scientific notation and standard notation. So your next section of this lesson is going to be a little song on scientific notation that will hopefully help you understand how to make that conversion. And again, we only use scientific notation to describe really big and really small numbers.
A number really big without tiring out your hand, you dig? Say it's a trillion, that's 1 or 12 zeros. 1 million million, I ain't writing that out, bro. Easy way to do it, everyone from every nation uses it. It's called scientific notation. Let's start with a number like 110. Look for the decimal, it's at the end. Move the decimal to the left a certain number of spaces until there's 1 space left, that's 2 places. Now you got 1.10 not done yet. Add it times 10 with an exponent. Exponent's gonna be number of places you moved. In this case, that's gonna be 2. Now you got 1.10 times 10 to the 2. Drop off the 0, make it easier to write, dude. Yeah, that's scientific notation. Call it side note. Got about 100 trillion cells in the human body. Or 1 times 10 to the 14th. Sun is 92,955,807 miles away. Right inside note, make it easier to say. Find the decimal, move it to the left. That's 7 places till there's 1 left. Round the decimal to 9.3 cause it's easier than writing out 9.2955807. Use side note so it doesn't take an hour. 9.3 times 10 to the 7th power. Side note also used for really tiny numbers, so writing them out doesn't take the rest of the summer. Virus of the common cold is 0.0000003 meters, bro. Move the decimal to the right this time. 8 places, come on man, don't be blind. Got 3.0 times 10 to the -8th. Easy to write now, man, side note is great. In your computer, you got a processor with the width of 0.000000065 meters, or 6.5 times 10 to the -8th. You're using it right now. Sign of the exponent, easy to remember. Simple rule to use beginning this September. Large number sign is positive. Small number sign is negative. Sign note uses times 10 with an exponent. An easy way to rewrite is what I meant. Whether big or small is 4 amounts that are extreme. Check all your work, keep the math clean. Population of US is 3 times 10 to the 8th. Fraction of the world, can you estimate? Total is about 7 times 10 to the 9th, dude. First 7 divided by 3 is about 2. Divide the exponents by subtracting. 9 minus 8 is 1 exactly. That's how you do it to get 10 to the 1. Now you got 2 times 10 or 20, son. One human chromosome contains about 220 million base pairs, or 2.2 times 10 to the 8th. in E. coli bacteria is 0.000002 meters long, or 2 times 10 to the minus 6. The distance to Mars is 78 billion meters, or 7.8 times 10 to the 10th. For numbers that are really large or small, gotta use that sine note.